All right, Chapter 1, Module 8, Amplifiers. Single stage audio amplifier. First single on Chapter 1. First single stage audio amplifier, Part 2. First stage single audio amplifier shown in Figure 123, circuit with the A class common emitter with the RC couple, the transistor of the audio amplifiers, capacitor 1, coupling capacitor with the couple of the input signal of the base of the transistor 1, the resistor of the U with the develop the input signal to provide the base of the bi for the transistor 2, transistor 1, resistor 2, the U with the base for the emitter with the provide temperature with stability with the transistor 1, capacitor 2 that provide the decoupling power of the feedback of the signal would be developed in resistor 2, resistor 3 collector load for the transistor 1 develop the output signal and capacitor 3 with the coupling circuit with the coupled to the output signal for the next stage of the voltage represents the current supply voltage that sends the transistor common emitter configuration is provided with the voltage and amplification input output signal 180 degrees out of phase of the input and outer impedance are both medium. Alright, have voltage collector, current collector going through the resistor 3 and capacitor 2 goes out to the output while the resistor, transistor is in between the circuit of the resistor 3 and resistor 1 capacitor, resistor 2 and 3 capacitor input signal grounded. There's nothing presented within the circuit that you should understand all the functions that come on within the circuit if you do not look at the various sections presented earlier in the chapter. Second single stage audio amplifier shown in Figure 120, circuit is class A with the common source of the RC coupled field effect transistor audio amplifier capacitor 1 coupling capacitor coupled to the input with the signal of the gate of the Q1. Transistor 1, resistor 1 used to develop the input signal of the gate with the transistor 1, resistor 2 used to buy for the source of the transistor 1. Capacitor 2 used to decouple the signal developed in the resistor 2, keeping them effective at the source of the transistor 1, resistor 3 drain load of the transistor 1, develop the output signal, coupled over the output signal to the next of the stage of the voltage supply of the drain of the transistor 1 sent to the common source of the configuration of the input and output signal of 180 degrees. Alright, so obviously the voltage drains going through resistor 3 and the capacitor at the end, while the capacitor 1 goes through resistor 1 and resistor 2 and capacitor, resistor 1 and transistor 2 has a capacitor on the inside of it. If you don't remember the field effect transition work, refer to the Neets module 7 in introduction, solid state device and power supply. Third single stage audio amplifier shown in Figure 125, the class A common emitter of the transformer coupled with the transistor audio amplifier. The output of the device of the speaker is connected with the secondary winding transformer, the capacitor with the coupling capacitor, which couple the input signal with the base of the transistor 1, the R1 developed the input signal with the R2, the U of the base emitter with the transistor 1 provided the temperature of the stability of the capacitor, the decoupling capacitor, resistor 2, the resistor 3, U of the base of the emitter with the transistor 1, primary transistor 1, transformer 1 winding collector over the transistor 1, develops the output signal of the transformer winding coupled the output signal with the speaker that provides the impedance matching with the output of the impedance of the transistor medium and the impedance of the speaker low. 125 is a single stage audio amplifier show the collection current input signal going through capacitor 1 parallel works with there are two parallels and a third parallel, but the first parallel would be your resistor 1 and resistor 2. Resistor 2 has its parallel between resistor 1 and 2, and the so you have, and then their second parallel would be resistor 3, transistor 1, transformer 1, speaker, and transistor has source, power, drainage, and drainage. Phase supporter support sometimes necessary to provide two signals with equal amplitude 100 degrees 80 out of phase. You'll see one of these two signals a little later in the chapter. The two signals can provide the M signal input signal with the use of the phase splitter. The phase splitter's device provides two signals with a different phase in phases from each other other than signal input signal as in a block diagram phase splitter. On block diagram of the phase splitter, one way the phase splitter can be made is with the center tap transformer. As you may remember the study with the transformer, when the transformer and secondary winding the center tap, two equal amplitude signals are produced. The signal with the 180 out of phase with each other, so the transformer center tap secondary fulfills the definition of a phase splitter. Transistor amplifier configuration acts as a phase splitter. One method of doing so is by voltage collector current, the capacitor 1 input signal, the transistor is basically surrounded by resistor 2, 3, and 4, and 5. 1, 2, and 3, and 4. and the source and the capacitation the capacitor 2 and 3 is your phase splitters. Capacitor 1, input signal coupling capacitor coupled with the input signal of the base for the transistor 1. The resistor 1 develop the input signal of resistor 2 and 3 to develop the output signal of resistor 2 and 3 are equal to resistance and provide equal amplitude. Output signal capacitor 2 and 3 couple the output signal with the next stage. Resistor 4 is to provide the proper bias for the base for the transistor 1. The phase splitter for the actual signal transistor combined with the quality for the common emitter of the common collector configuration. Output signals are equal to amplitude. Input signals are 80 degrees out of phase with each other. If the output signal is much larger amplitude, input signals the circuit shown in figure 128 will be used. Figure 128 shows the two-stage phase splitter with the C1 coupled to the input signal of the base for the transistor 1. The resistor 1 develop the input signal provide the bias for the base for the transistor 1. Resistor 2 provide the temperature stability for transistor 1. Capacitor 2 to decouple the signal with the emitter of the transistor 1. Resistor 3 develop the output signal of the transistor 1. Since the transistor 1 is configured with a common emitter amplifier, the output signal of the transistor 1 is 180 degrees out with the in phase with an input signal and larger amplitude. Figures see capacitor 3 coupled with the output signal of the next stage through the resistor 4. Resistor 4 allows a small portion of output signal to be applied to the base of the transistor 2. The resistor 5 that develops the input signal to provide the bias for the base for the transistor 2. Resistor 6 for the bias and temperature stability of the transistor 2. The capacity to decouple the signal of the emitter of the transistor 2. Resistor 7 that develops an output signal of the transistor 2. Transistor 2 is configured as a common emitter amplifier, so output signal is 180 degrees out of phase with the input signal of the transistor 2. With the output signal from transistor 1, the input signal of transistor 2 is 180 degrees out of phase for the original input signal, so the output of the transistor from transistor 2 is phase with the original input signal of the capacitor 5 coupled with the output signal of the next stage. So the circuitry shown provides the two input signals of 180 out of phase with each other. The output signals are equal amplitude with each other but larger than input signals. Our figure 128 shows the two-stage transistor phase. Notice that they both have a source and the drain with one resistor and the other one with a resistor and capacitor on both transistor 1 and 2. And then transistor 1 leads to a resistor with a voltage current collection, a capacitor 3, and then is the line. Also, transistor 2 has its own resistor 7, capacitor 5, voltage current collection. Alright, push-pull amplifiers. One of the uses of the phase splitter is to provide input signal with the signals and stage amplifier. You have the two transistor figure in such a way that the two outputs 180 out phase with each other. With the combine these allow more gain than one transistor could supply by itself. The push-pull amplifier is used the higher output with a good fidelity need. With the receive output stages, public address amplifiers, AM modulators, and for example. The circuit shown in figure 129, class A, the transistor push-pull amplifier, class A, B, and class B operation could be used. The class operation that discussed earlier in the top of the phase splitter amplifier transformer T1 winding. Although one of the phase splitters earlier with the topic could be used, the resistor 1 provided the proper base for the transistor 1 and transistor 2. The tap secondary of the transformer 1 winding develops two input signal base of the transistor 1, transistor 2, half output and signal. Input signal will be applied to transistor 1 and the other half of the transistor 2. The transistor 2 winding combines the couple of the amplified output signal with the speaker that provides the impedance. So you have your transformer 1 winding a resistor between the transformer 1 that is divided into the transistor 1 and transistor 2. The voltage current is also grounded between both transistor 1 and 2. And the current from the transistor 1 and 2 goes in the transformer 2 winding into the speaker. Alright, summary, chapter 1.